Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 237. Please turn to it. Page number 237, and today is our lesson number 335. This problem that you see there on page number 237 is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single problem from the first edition. If you are interested in watching the original solution at a slower pace, you will find it on day number 121. Today we're going to redo it, but at a little bit of a faster pace. If you need a little bit more in-depth help, day 121 is what you need. So here we go. We are given two inequalities. X minus 3y, we are told is less than or equal to negative 6, and 2x plus y, we are told is less than or equal to negative 1. Let's call this inequality 1 and 2. Now the very first thing we need to do here is to figure out how to plot these inequalities on a graph. Now a lot of things we're going to do today, I'm not going to explain in too much of a detail for a second reason. The second reason is that I am hoping that you have already watched yesterday's video 334. Yesterday we did solve a bonus problem, a system of inequality based on the two equations that are given to you on the opposite page 2.8.2. If you have not watched yesterday's video, stop right now, watch yesterday's video. I want you to watch yesterday's video first, 334 first, and then I want you to try to solve this thing 2.8.3 on your own and see if you can come up with the same solution as it is presented in the book. And then and only then I want you to compare your work, the work that you do yourself, with the work that we are about to do together. That's the deal. But you will find that you will always learn more if you try to solve these problems yourself first. Anyway, I'm done with my sermon. Amen. Thank you. So the first thing we need to do is to look at is to take these inequalities and treat them as if they were equalities. As if they were equalities. And therefore what we have here is x minus 3y equals 0. And we want to see very quickly how to plot this thing. And the quickest and the simplest way to figure out how a linear equation is going to look like on a graph is to locate its intercept. So let's do that. When x is equal to 0, you will find 0 minus 3y equals negative 6, and therefore y equals negative 6 over negative 3, which means y equals 2. No, y does not equal to 3y. Why do I have here 3y? It should be 2. It is 2. And therefore the y-intercept y-intercept is where x is 0. X is 0 along the y-axis, and we find that the y-intercept turn out to be 0 and 2. So that's the first point. Let's put it here. 1, 2, 0 and 2. I'm looking at my graph here, eventually how we want it to look. Let me redraw this thing. I don't like the line going like this. Just give me 1 second. I want to see what the other one looks like. Okay. Zero and 2. Now let's look at the x-intercept. And for x-intercept is where the line cuts the x-axis, which is why it's called the x-intercept, and when the line cuts the x-axis, that's where the y-coordinate is going to be 0. So we plug in 0 in this thing here, x minus 3y equals negative 6, which means x minus 3y, y is equal to 0, and this drops out, and x equals to negative 6. X equals to negative 6. And we have our x-intercept is going to be negative 6 and 0. Let's do it here. Negative 6 and 0. 1, 2, 3, 4, 5, 6. One, two, three, 4, 5, 6. It does not need to be precise, obviously. We're not drawing it to scale. It doesn't have to be exactly, and like I said, it doesn't need to be precise. But you do need to put in sufficient effort, a reasonable amount of effort, to make sure that it does not look too wacky, because otherwise the graph is not going to come out very nice. So here we go. Here's our line. The first line is this. Once we have located the line, then and only then we ask ourselves, how does this come into play? The fact that it is greater than or equal to, not equal to, but greater than or equal to. So now we're going to ask ourselves that question. The question here is, the inequality that is given to us is x minus 3y is greater than or equal to negative 6, not equal to. So let's see what that looks like. That's it. We're done with the line there. What we're trying to figure out is, where is the solution region? Where is it going to fall? Is it going to fall below the line, or is it going to fall above the line? Here, the solution to this inequality is not all the points that we see on the line, but is the entire region, the region that falls either below it or above it. Let's find out. And again, if you have watched yesterday's video, you will know, we learned yesterday, that the quickest, easiest, simplest, most efficient way of figuring out where the solution region lies is to simply try out the point of origin. And ask yourself, where does that point of origin lie? Let's find out. X minus 3y, x minus 3y is greater than or equal to negative 6 when x is 0 and when y is 0. 0 minus 0 is 0. Is 0 greater than or equal to 6? The answer is no. 0 is not greater than or equal to 6, which means the solution does not lie below it, it lies above it. Something has gone wrong here, because x minus 3y, oh, sorry, it is not 6. You see, I realized I made a mistake here. It's not 6, it is negative 6. It is negative 6. This is negative 6 here, not 6. I almost made a boo-boo. So we ask ourselves, is 0 greater than or equal to negative 6? And of course the answer is yes. 0 is indeed greater than negative 6, which means the solution region must contain this point. The solution region must contain this point, which means the solution region is found here. Very good. That's our solution region. That's the first inequality. We're done with it. Let's look at second inequality. Second inequality says 2x plus y is greater than or equal to negative 1. So we start out with the equality first. When x is equal to 0, 2 times 0 plus y equals negative 1, which means y equals negative 1, which means it goes through 0 and negative 1, which means it goes through 0 and negative 1. 0 and negative 1. 0, x is equal to 0, y is negative 1. It goes through this point right here. It goes through that point. Let's erase this origin, we don't need it. Zero and negative 1. Let's find out the y-intercept. Oh, 0 and negative 1, sorry. 0 and negative 1 would be somewhere here. That was our x-intercept. That was our x-intercept. This is 1 and 2, so 1 is right here. X is equal to 0 along y-axis. X is equal to 0 along y-axis. As I always tell you, it's okay to make a mistake. It's okay to make not only a mistake, but it's okay to make mistakes. It's perfectly fine. As long as you're alert enough, as long as you're awake enough to catch your mistakes right away. I just made 2 mistakes. One mistake I made was where I forgot to put a negative sign there, and I was about to say, I almost said that the solution region lies above it, and then we caught ourselves. We realized that it is -6, not 6. And here, what we just found out is the y-intercept. It is the y-intercept because that's where x is equal to 0. So it's not -1, 0. It is 0, -1, which is down here. Now, when y is equal to 0, you will have 2 times x plus y is equal to -1. 2 times x plus y is equal to 0, which means 2x is equal to -1, which means x is equal to -1 over 2, -half. This was our 1, so -half is here somewhere. Oh boy, this is going to be very tricky. This is going to be very tricky. Let's see what I can do. I wish I had a long ruler that I could use. Actually, I see something right there. I'll be back in a second. First, I'll do. Okay, these are the 2 points the line goes through. Just give me 1 second. It is not a ruler, but we'll improvise. It will do the job just fine. It is actually a paint mixture. I don't know why the paint mixture, what the paint mixture is doing there, but anyway, this will do the job. So here are the 2 points. That's your line. Now we have to ask ourselves. Does the solution to this line, the solution to this inequality that we have, because we are no longer dealing with equality, we have located the line. Now we're going to deal with the inequality part, which is 2x plus y is not equal to -1, but it is greater than or equal to -1. It is greater than or equal to -1. Again, the trick is very simple. Ask ourselves, where does the origin lie? Where does the origin lie? So 2 times 0 plus 0. We just substitute the coordinates of the origin, and we ask ourselves, does that satisfy the inequality? If the answer is yes, then the solution region must contain the origin. If the answer is no, the coordinates of the origins do not satisfy the inequality, then the solution region cannot contain the origin. So solution region must be the other part. It's either left, when you draw a line, it's either left or right, up or down. That's all there is. So 2 times 0 is 0 plus 0, 0. Is 0 greater than or equal to -1? The answer, of course, is yes. 0 is greater than -1. 0 is greater than -1, which means the solution region must contain the origin. Solution region must contain the origin. We are almost done. So now we know our solution must lie. This was our line, the red line. This was our line, red line. And here is the origin. And we just found out that the solution must contain the origin because the origin satisfies the inequality, which means it lies on this side. There you go. That's your solution region. That's our solution region. Our solution region lies where the 2 area overlap, which starts from here. From here down to here. There you go. By golly. And that is exactly what you see there in the book. That is exactly what we see there in the book. And that's all there is. That's it, we're done. let's see what we have for tomorrow. We turn the page. Tomorrow we'll talk about what is known as line of symmetry. We'll understand that concept, what the line of symmetry is, and how to draw, how to come up with the mirror image of something that is given to us. If an equation of a line is given to us, first of all, how to draw that line, which we already know, but we have done it for the last couple of days, which is simply to look at the two intercept and draw the line. And once we have drawn the line, the next question is, how do we go about drawing its mirror image? And that has to do with what is known as the line of symmetry. We'll learn that tomorrow. Okay? Bye now.